Hi all, let's solve this question on derivative. In this question, we are given a differential equation, we are given this derivative equation, and we are given one point on the curve of the function. Our target is to find equation of the curve. So equation of curve means y equal something. So we're not finding derivative, rather we are getting rid of derivative in this question. We are removing derivative. So let's start now. This is equation. Derivative equation is dy dx is equal to 3 times root x minus 6. I can write this equation in more simplified form. 3 times x power 1 by 2 minus 6. So this is the differential equation of the curve. Differential equation of the curve. And we are given a point P 1, 6, which is on the curve. So we are given two things. First thing, differential equation. Second thing, a point on the curve. And in the A part, we have to find equation of the curve. Let's start A part here. So from this differential equation, I want to remove this derivative thing, ddx. Definitely, we're gonna apply anti-derivative because as we guys understand that integration is nothing but antiderivative. It means whenever we want to remove this derivative, we should take integration. So integrating both sides, so I write here now, integrating both sides. I'll get here integral of dy dx with dx is equal to integral of 3 times x power half minus 6 dx. So integrating both sides of the first equation, which was differential equation. Now we're going to apply power rule. So here, this integration and this derivative being anti to each other, opposite, antonyms, they're going to cancel out. We're left with y on left side. So y equals, this 3 being a constant coefficient can be out of this integration. Now by power rule, integration of x power half will be x power half plus 1 over half plus 1 by using power rule. Negative 6, integral of dx is x plus c. Okay, so for a note, integration of dx will be x. Again, derivative, differential operator, and integration will cancel out. We get x here. Or in simple words, you can say integral of 1 is x, because derivative of x is equal to 1. If derivative of x is 1, that means integral of 1 should be x. So that's why minus 6 into integral of 1 will be x. Now, we got this equation now, but it's not the final answer to A part. In A part, is asking equation of the curve. We got equation of curve, y equals something, but we need to get rid of this c now. Let's simplify a bit more. Y equal 3 into x power 3 by 2. This is 3 by 2 down. When it comes up, it gets inverted, 2 by 3 minus 6x plus c. So this 3 and this 3 cancel. We're left with y equal 2 times x power 3 by 2 minus 6x plus c, or for the simplification, y equal 2 into x power half, which is 2 times x into root x minus 6x plus c. So this is equation, but still we have constant to get rid of. Now the equation is y equal 2 times x root x minus 6x plus c. I write next page now. Y equal 2x root x minus 6x. Y equal 2x root x minus 6x plus c. Now we are given one point on the curve, and the point was P16. So this point P16 lies on the curve. So that means we can plug in x equal to 1 and y equal to 6. It's gonna satisfy this equation because this point is on the curve, whose equation is this one. So plug in y equal to 6 and x equal to 1, we get 2 times 1 times root of 1 minus 6 times 1 plus c. Simplify further, you get 6 equal to 2 minus 6 plus c. It means c is equal to 12 minus 2 is 10. So plug in back here, value of c. What you get here? Y equals 2x root x minus 6x plus 10. So this is equation of curve. This is equation of the curve. And the A part is done. So again, A part was find the equation of the curve. Now we're going to start B part. In B part is asking the coordinates of stationary point, critical point, and the nature of those critical point or stationary point. Very simple. Now we got equation of curve. In the B part, to find stationary point or the critical point, B part, we just need to take derivative, right? If I take derivative of this one, it should be same here, this one. If I take derivative of this equation, it must be same because we got equation from this derivative equation, right? So derivative is 3 root x minus 6. So to find stationary point, we should take this derivative equal to 0, which is 3 root x minus 6. So taking derivative equal to 0 means dy dx equal to 0. Our target is to find stationary points, okay? It means derivative is 3 root x minus 6. So that means 3 root x minus 6 equal to 0. It means root x is equal to 6 by 3 is 2. That means x is equal to square of 2, which is 4. So x is equal to 4, squaring both sides. Now we got x equal to 4, we need to find y. So plug in x equal to 4 in this equation of the curve. So we're going to get y equal to 2 times 4 times root 4 minus 6 times 4 plus 10. If we simplify further, what do you get here? 4 times 2, 8. 8 times 2, 16, right? So 16 minus 6 times 4 is 24 plus 10. So we get here y equal 16 plus 10 is 26 minus 24 is 2. So y is 2 and x is 4. Let's check again. 2 times 4, 8 times 2, 16 minus 6 times 4, 24 plus 10. So 16 plus 10, 26 minus 24 is 2. So x is 4, y is 2. So x is 4, y is 2. So stationary point is basically 4, 2. Okay, right here now, stationary point is 4, 2. Next target is to find the nature of this. We got stationary point, coordinates of stationary point or the stationary point we got already. And now next target is to find nature. What is the nature? Whether this stationary point is a maximum or a minimum. For that, we need to find second derivative, d2y dx2, which is derivative of the derivative. Derivative of first derivative. So first derivative we already given. How much is? First derivative was 3 root x minus 6. So derivative means derivative of 3 root x minus 6. Let's check again. Derivative is 3 root x minus 6. So second derivative means derivative of derivative, which means derivative of 3 root x minus 6. Root x is x power half. Again, by power rule of derivative, this 3 being constant will come out. 3 into derivative of x power half by power rule. Power comes in front. X power half, that power minus 1. minus derivative of a constant being 0. Derivative of constant is always 0. So if we simplify further, we'll get here 3 by 2 into x power minus half. Changing it to root, you get 3 by 2 root x. So this is the second derivative, second order derivative. If we plug in stationary point x value into this derivative, second derivative, what will happen? So d2y dx2, plug in x equal to 4 into this derivative, what we will get? We get here 3 by 2 root 4, which is 3 by 2 times 2 is 4. It's a positive. Second derivative is positive. So second derivative is positive. Whenever second derivative at a stationary point is positive, that stationary point is maximum or minimum. It is maximum or minimum. We have learned in the previous lessons that if the derivative is positive, the point is, if the second derivative is positive, it's a point of maximum. And if the second derivative is negative, it's a point of minimum. Is that okay? So if the second derivative is positive, it's a point of minimum. Sorry, if the second derivative is positive, it's a point of minimum. We have to do it again. Let me erase. Okay, if second derivative is positive at a stationary point, that stationary point is a point of minimum. And if it is negative, that stationary point is a maximum. So in our case, when we plug in x equal to 4, the x value of stationary point, we got second derivative positive. So that means this stationary point, which is 4, 2. So stationary point 4, 2 must be a minimum. Must be a minimum point. So that's the nature of stationary point. In our case, stationary point is a point of minimum or a minimum point. So that's with this we are done with the B part. In the A part, we solved the curve from the differential equation. The curve was y equal to x root x minus 6x plus 10. Then the B part, we find the stationary point by taking derivative equal to 0 and then putting that stationary point into the second derivative, and we find sign to be positive. That means stationary point is a point of minimum. That's it. I hope you guys understand. Take care. Goodbye.